Welcome, ladies, gentlemen, flirts and flirtettes. The final experiment is over. It's finished. It's done. And it hasn't even started yet. There is still more than a day left until it starts, and Critical Think already debunked the flat Earth just by flying from Sydney to Santiago. The final experiment has a tracking app, but it can't show the data in a Gleason's map. Since there is no definitive flat Earth map application, we need to create one. This is a Mercator map wrapped around the cylinder. The continents look okay in the vertical direction, also around the equator, but they are really stretched around the polar areas. Almost as if this cylindrical map was projected from a globe. I don't know. It's easy to convert this to an azimuthal equidistant map. First, we need a latitude and longitude grid. This will suffice. And we need to project each point with a straight line onto the disk. This preserves the distances along the longitude lines, but heavily distorts around the latitude lines. If we reduce the top radius to 0 and also reduce the height of the cylinder to 0, then we will get a projection onto the flat disk. I made this little animation to visualize the projection. Let's hit the spacebar. Not that kind of spacebar, this kind. Now our map is ready, and let's see why the Sydney-Santiago flight instantly debunks the flat Earth. Let's put the tracking data on the AE map. As you can see, Critical Think took the longest way around the circle, and the more logical way would be a straight line, maybe stopping in San Francisco on the way for refueling, but could be a direct flight. And for some reason, the pilots flew all around the edge, almost as if there is some huge no-fly zone in the way or something, I don't know. The actual flight path doesn't deviate from a circle too much, so let's draw a circle around this, and let's call this distance r. Then we can calculate the circumference of the circle, which is 2 pi r, and the actual flight took half of the circumference, so let's divide it by 2. And we also have the diameter, which is the straight line path, which is 2 times r. So let's calculate the ratio of these two, which is pi over 2, or 1.57 roughly. And please show me any airline which will say that let's take the longer route and let's make it cost 1.5 times more for the customers, and let's take 1.5 times more time to get there. I don't think any airline exists that would do that. I did not create this flat Earth map to track the final experiment, but since it was easy to port the tracking data onto this map, I decided to do it, and you can watch it too. The code is on GitHub, and also the link is in the description. And in a follow-up video, I will explain how it works and why it was created and what was the original purpose. It will be an interesting video. For an average person, it's pretty easy to understand why this flight path needs to be the shortest one, and why it looks like so distorted on this AE projection. I like this quick evidence for the globe and quick debunk for flat Earth. We can collect all sorts of astronomical data and visualize it by forcing it on the flat Earth map or putting it on the globe map. But a simple flight path can just be enough evidence sometimes. All the participants can go home now. Cue the clown music.
If this happens to be the first video you ever watched on YouTube, allow me to tell you the rules. At the end of the video you must hit the subscribe, thumbs up, and bell buttons. You must leave a comment under the video. Farewell, until my next video.